Okay, hi everyone, welcome back to this video series on cryptocurrency. Irreversible upgrades. Because soft forks create transactions with additional consensus constraints, they become irreversible upgrades in practice. In a soft fork upgrade were to be reversed after being activated, any transactions created under the new rules could result in a loss of funds under the old rules. For example, if a CLTV transaction is evaluated under the old rules, there is no time lock constraint and it can be spent whenever. Therefore, critics contend that a failed soft fork that had to be reversed because of a bug would almost certainly lead to a loss of funds. Soft fork signaling with block version. Since soft forks allow unmodified clients to continue to operate within consensus, the mechanism for activating a soft fork is through miners signaling readiness. A majority of miners must agree that they are ready and willing to enforce the new consensus rules. To coordinate their actions, there is a signaling mechanism that allows them to show their support for a consensus rule change. This mechanism was introduced with the activation of BIP34 in March 2013, replaced by the activation of BIP9 in July 2016. BIP34 signaling and activation. The first implementation of BIP34 used the block version field to allow miners to signal readiness for a specific consensus rule change. Prior to BIP34, the block version was set to 1 by convention, not enforced by consensus. BIP34 defined a consensus rule change that required the Coinbase field input of the Coinbase transaction to contain the block height. Prior to BIP34, the Coinbase could contain an arbitrary data the miners chose to include. After the activation of BIP34, valid blocks had to contain a specific block height at the beginning of the Coinbase and be identified with a version number greater than or equal to 2. To signal the change and activation of BIP34, miners set the block version to 2 instead of 1. This did not immediately make version 1 blocks invalid. Once activated, version 1 blocks would become invalid and all version 2 blocks would be required to contain the block height in the Coinbase to be valid. BIP34 defined a two-step activation mechanism based on the rolling window of 1000 blocks. A miner would signal his or her individual readiness for BIP34 by constructing blocks with 2 as the version number. Strictly speaking, these blocks did not yet have to comply with the new consensus rule of including the block height in the Coinbase transaction because the consensus rule had not yet been activated. The consensus rules activated in 2 steps. If 75%, 750 of the most recent 1000 blocks are marked with version 2, then version 2 blocks must contain block height in the Coinbase transaction or they are rejected as invalid. Version 1 blocks are still accepted by the network and do not contain block height. The old and new consensus rules coexist during this period when 95%, 950 of the most recent 1000 blocks are version 2. 1 blocks no longer considered valid. Version 2 blocks are valid only if they contain the block height in the Coinbase as per previous threshold. Therefore, after all blocks must comply with the new consensus rules and all valid blocks must contain block height in the Coinbase transaction. After successful signaling and activation under the BIP34 rules, this mechanism was twice more to activate soft forks. BIP66 stricter encoding of signatures was activated by BIP34 style signaling with a block version 3 and invalidating version 2 blocks. BIP65 check lock time verify was activated by BIP34 style signaling with a block version 4 and invalidating version 3 blocks. After the activation of BIP65, the signaling and activation mechanism of BIP34 was retired and replaced with the BIP9 signaling mechanism described next. The standard is defined in BIP34 block version 2 height in Coinbase. BIP9 signaling and activation. The mechanism used by BIP34, BIP66 and BIP65 was successful in activating 3 soft forks. However, it was replaced because it had several limitations. By using the integer value of the block version, only one soft fork could be activated at a time, so it required coordination between soft fork proposals and agreement on prioritization and sequencing. Furthermore, because the block version was incremented, a mechanism didn't offer a straightforward way to reject a change and then propose a different one. If all clients were still running, they could mistake signaling for a new change as signaling for the previously rejected change. Each new change irrevocably reduced the available block versions for future changes. BIP9 was proposed to overcome these challenges and improve the rate and ease of implementing future changes. BIP9 interprets the block version as a bit field instead of an integer. Because the block version was originally used as an integer, version 1 through 4, only 29 bits remain available to be used as a bit field. This leaves 29 bits that can be used independently and simultaneously signal readiness on 29 different proposals. BIP9 also sets a maximum time for signaling and activation. This way, miners don't need to signal forever. If a proposal is not activated within the timeout period defined in the proposal is considered rejected. The proposal may be resubmitted for signaling with a different bit, renewing the activation period. Furthermore, after the timeout has passed and a feature has been activated or rejected, the signaling bit can be reused for another feature without confusion. Therefore, up to 29 changes can be signaled in parallel, and after the timeout, the bits can be recycled to propose new changes. BIP9 was proposed to overcome these challenges and improve the rate and ease of implementing further changes. BIP9 interprets the block version as a bit field instead of an integer. Because the block version was originally used as an integer, versions 1 through 4, only 29 bits remain available to use as a bit field. This leaves 29 bits that can be used to independently and simultaneously signal readiness on 29 different proposals. BIP9 also sets a maximum time for signaling and activation. This way, miners don't need to signal forever. If a proposal is not activated within the time period defined in the proposal is considered rejected. The proposal may be resubmitted for signaling with a different bit, renewing the activation period. Furthermore, after the timeout has passed and the feature has been activated or rejected, the signaling bit can be reused for another feature without confusion. Therefore, up to 29 changes can be signaled in parallel, and after timeout, the bits can be recycled to propose new changes. Therefore, up to 20 can be signaled after timeout, resignaled to propose new changes. Proposed new changes are identified by a data structure that contains the following fields. Name a short description used to distinguish between proposals. Most often the BIP describing the proposal as BIP-N, where N is the BIP number bits. 0 through 28, the bit in the block version that miners use to signal approval for this proposal. Start time, the time based on median time post, or MTP, that signaling starts after which bit value is interpreted as signaling readiness for the proposal. End time. The time based on MTP after which the change is considered rejected if it has not reached the activation threshold. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.